Hello and welcome to the episode 3 of PyTorch Code Deep Dive. In the last episode, we learned how iterating works with DataLoader. Data collating is an important step required to put final batch of data together. In this episode, we will deep dive into how Default Collate function works. I will reuse dataset from previous example. This time, I'm not creating DataLoader. Instead, there's just a list of items retrieved directly from the dataset. This list is passed to collate function provided by PyTorch. Let's deep dive and check what it does. Firstly, element type of the list is captured. There's quite assumption the type is same over the whole list. In this case, it's a tuple. Since mapping function was passed as parameter, there's a check if this mapping is supported. Let's check which keys are supported in general. We can see that this function supports tensor, numpy array and types, simple numeric types and string, but there's no tuple in the mapping. There's also an additional check if elements are subtypes of any of the supported types. As a next step, there's a check if list contains map types. Next, the name tuple, and the last is sequence. Since tuple is a sequence, the code checks for the number of items in the element, in this case 2, x and y. At this point, we need to transpose batch of 8 items, 2 elements each, into list of 2 items, 8 elements each. Once we have this form, it's sufficient to call recursively collate on each of the 2 items. Therefore, for the first item, there's a tuple of 8 tensors. Since element type is tensor, it's supported by the mapping function. When deep diving into the function, we reach the function that handles batch of tensors. There are initial constraints that tensor cannot be nested nor sparse. I'll skip memory optimization for now. Finally, all the tensors in the list are stacked along dimension 0. For the next element, the handle type is integer. There's a tuple of 8 integers. Since integer is supported by mapping function, we can deep dive into it. The function is about creating one-dimensional tensor out of sequence of integers. There's similarly working function that handle float types. Another registered function is handling string. Note that there is no specific collation for string type. Strings are returned as they are. Additionally, there's support of numpy arrays. Numpy arrays are handled by converting each numpy array element in the list into tensor and recursively calling collate function. Let's go back. As a result, there's a list of 2 elements. Each element is a tensor, which is target data type. Since Default Collate support mapping types, let's modify input data to check how it's handled. This time, items list contains dictionaries, each containing X and Y key. Let's run the same collate function over this newly created list. Now, each element is a dictionary, and we know the default mapping function does not support dictionary. When mapping type is handled, the first element is cloned in order to copy structure of the dictionary. For each key of this dictionary, collate is called recursively over the list created by the elements from the original batch at specified key. So values at each key are collated together. The element type is tensor, and we already know this scenario. Finally, the returned value contains single dictionary with X and Y keys and two collated tensors. Collate function is wrapped by default collate function. While collation the function can be set to any other user-defined function when constructing DataLoader, it may be also sufficient to modify or replace default collate function map in order to add support for any not yet supported type. In this video, I showed in detail how default collate works. In the next episode, I will show how sampling can be used to shuffle dataset elements. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.